Swayam Prabha. Digital India. Educated India.
Welcome to the next big idea. An incredible journey of innovation, passion, and game-changing ideas. Let's see what this team brings to the table.
Can you imagine a situation where your hand keeps shaking and you can't eat food? Well, Parkinson's patients go through this each and every day with each and every meal. 2 years ago, I was at a family function and I saw my uncle Arjun, who has Parkinson's. It was very hard for him to eat. Using the spoon, all of the food was spilling out, and I felt deeply dissatisfied with this. I empathized with this and I wanted to come up with some solution for this. So, about myself, I'm Aravanil, who's studying in 12th grade from Bangalore. So, I've been into robotics since the past 8 years, and I really want to create a solution for this. So, this is the team. Me and my team Vidyasagar are the founders of this company called Robo Electro Steam Studio with our mentor Ashwini. So what is the problem with Parkinson's? Parkinson's patients have tremors. So their hand keeps shaking like this all the time. So while eating with the spoon, all the food falls off and it's really hard for them to eat. So they have to depend on another person to feed them. So due to this, they feel dependent. They feel that I'm relying on somebody else. That person should feed me. So they feel that I'm burdening another person. So because of this, they feel socially embarrassed. They can't eat properly in social gatherings. They spill all the food and no person would like to sit with them. So this is the main problem which we want to target. So the solution which we have come up with is a smart self-stabilizing spoon, which even if there are tremors, the front part of the spoon is always parallel to the ground. So even if there are tremors, the food won't spill out of the spoon. So we are currently in the process of validation, and we have tied up with RV College of Physiotherapy, who's helping us to validate this product by testing on several patients, including Parkinson's and other stroke patients who have tremors. So this product includes mechanical design, electronics, and software. So it's a combination of all the three and electronics. So in the future, we'll also implement machine learning and IoT so that the accelerometer and magnetometer data can be logged and it can be shared to a cloud so that the doctors can get more information about the Parkinson's patient and his tremors. And we'll implement machine learning so that the PID algorithm, which is implemented inside, which will control both the motors, can automatically adapt to the patient's tremors. So in Parkinson's, there are 3 types: low level, medium, and high. So this is the frequency levels. So in the low tremors, it is around 2 hertz to 4 hertz, the frequency of the tremors. And high, it ranges from 8 to 12 hertz. So currently, we are targeting only in the low to mid level tremors, which is from 2 to 7 hertz. So if we add machine learning, it will automatically adapt to the frequency of the tremors and adjust the PID values. So before starting off this project, we talked to some experts and doctors and also some Parkinson's patients. We got a lot of feedback and testimonials, which made us more aware about what was Parkinson's, what problems they faced. And after we finished the product, we gave it to a few Parkinson's patients who gave us more feedback. So coming to the value proposition, this tool is a lot different from the competitors because it's non-intrusive. There are some solutions which have electrodes, so it is intrusive, and it is not a reliable method. So our tool is a corrective impediment device, so it's non-intrusive. You can just hold it and you can start eating. And we tested out the accelerometer values, and we got to know that the spoon shakes 70% less than the hand. So if they're directly eating with the spoon without the smart spoon, more than 70% of the food spills off. And because of this and the data which we are logging into the cloud, the doctors will get a more detailed information about how the tremors are increasing or decreasing in the patient. And cost effective. This is one of our main unique selling points because there are 2 other competitors who are based in the US, and both of their prices are very high. Ours is almost half the price of that. So we want to target especially the Indian market because Indians, we want an economical product, a cost-effective product. We can't spend tens of thousands of rupees for one solution. So we are mainly targeting the Indian market. So if a Parkinson patient uses this, what benefits will he have? So first thing, he'll be independent. He need not depend on another helper to feed him. He can eat his food independently and reduce social embarrassment. He can worry less about spilling and focus more on enjoying the meal.
Can you move on to your product?
Yeah,
You're
I'll
working
show you
on
a
it.
demo also.
Yes.
Now I'll show you a demo of this. So all of these components, they're all 3D printed, and we are using a microcontroller which takes the values and accordingly adjusts the spoon also. So the first 5 seconds, it will calibrate the sensors. So even if there are tremors, the spoon is always parallel to the ground. So this is the roll compensation and this is the pitch compensation. Yeah. So coming to the market and traction, our TAM is around 8.8 million people because all over the world, the Parkinson's disease, the number of patients who have Parkinson's is around 8.8 million. And our SAM, which is 800,000, we want to acquire around 800,000 customers by the end of 2-3 years. And currently our SOM is 110,000, which is our target for the next 1.5 years. So this is a photo of us testing with a real Parkinson's patient. We got a few feedbacks from them, and we made the prototype better so that we can handle the customers better. And that certificate is a certificate from RV College of Physiotherapy, whom we have tied up with, and they will be helping us to validate this product with many other patients and publish a paper in the medical journal. After this, we are planning to file a patent also. So competitive analysis. We have 2 main competitors in this field who are based in the US, which is Liftware and Gynospoon. Both of these are at a cost of around $200, which is not at all suitable for the Indian market. So what is better in our product? Main thing is the cost. So currently this will cost around 5,500 rupees to manufacture, and we'll be selling at 8,500 rupees. So our net profit would be around 3,000 rupees, which is around 35%. So this is less than half the price of our competitors, which is our main USP. And coming to the revenue streams, we have primary revenue stream and secondary. Coming to the primary, which would be B2B sales directly to hospitals and physiotherapy clinics. So we can sell in mass to the hospitals and physiotherapy clinics, who can then in turn sell it to the Parkinson's patients and get more data about the tremors. Our secondary revenue stream would be acquiring tremor data. So using the accelerometer and magnetometer values, it can log the data and give more insights about the disease. So coming to the technology, first we designed all the components in CAD design using SolidWorks, and we 3D printed all the components, added the electronics, and made multiple prototypes. So initially we designed all the components in CAD, and then we 3D printed all of these. So all the white color components you see here, they're all 3D printed for the prototyping. This is the main sensor called as the IMU, which is the inertial measurement unit. It consists of accelerometer, magnetometer, and gyroscopic sensors, which will measure the tremors, acceleration, and angle values. It will send it to the Arduino Nano microcontroller. This runs a PID controller, which is proportional, integral, and derivative. It uses these values and it controls the motor drivers, which will in turn control the 2 motors. This is for the roll and this is for the pitch.
So I just want to know the durability of the product. Because people will be washing the spoons, all those things. Your product contains batteries, the sensors, the motor parts, the like the boards here, sensors, all those things. So I just want to know how long does it sustains, and if suppose there is any water leakage in the product, the water enters the like the boat. So what will be the scenario on that case?
Yeah. So this was one of our initial prototypes. And as you can see here, everything is exposed. All the motors, all the gears, they're all exposed. And we got some feedback from the Parkinson's patients, and we made it more covered like this. So currently this is not waterproof. And in the future, we would want to add a silicone covering, which will make it waterproof. And now we are using 3D printing, but in the future, we'll use silicone and injection molding, which will make it watertight.
I think that the radius of the spoon is much more bigger, because Parkinson people, like, they don't have a strength, they don't have a capability to catch the like the bigger product or the weight product. So how do you think this product will meet the requirements of the Parkinson patient?
So as you might know, Parkinson's patients, it's very hard for them to hold a spoon. Main reason because our spoon is very sleek. It's very small. We can easily grip it, but Parkinson's patients, due to their motor inability, it's very hard for them to hold. When we surveyed lots of professionals, they told that the ideal diameter is around 35 mm. Currently, 35 mm diameter, which is around this much. This is the optimum size.
I mean, you have a competitors, right?
Yeah.
In US.
Yeah.
So what's the weight of their product?
So liftware weighs around 150 grams and gyno spoon weighs around 450 grams. So there's a huge variation in the market. But when we talked to the experts and the real Parkinson's patients, and we actually tried out with a few different spoons. One which has a higher weight, one which has a very low weight, one which has a normal weight. And they told that if it's very light, their hand will shake more because lesser inertia and it will increase the tremors. But if it's very heavy, then their hand will get tired after a few minutes. So by that, we came up to the conclusion that the optimum weight is around 250 to 300 grams.
So, what innovative things do you have in your product?
The unique selling point or the innovative point of us is the cost effectiveness.
No, that is cost effective. So, what is the niche point over there?
Yeah. So these two products only stabilize the spoon, nothing else. Its sole purpose is to just keep the spoon steady. That's it. So what our future plans is adding IoT so that the tremor details, the accelerometer data can be logged and be sent to the doctors. So without the spoon, there'll be some amount of tremors, and with the spoon and the stabilization, the tremors would reduce. This data can be used by the doctor to further analyze the patient's recovery, if it's increasing or decreasing, or if it's just staying the same. Using this data is invaluable. We can use this to give to doctors, or we can use this data to give to other companies who are researching about Parkinson's.
See, what is your plan of action down the lane for next 5 years?
Yeah, our short-term plan for the next 1.5 years is to mainly focus on B2B, to hospitals and physiotherapy clinics, so that we can address a large scale in a less time. So we plan to sell around 3,000 to 4,000 products in the next 1.5 years. After that, getting investments and using their help, we can expand more and possibly even expand to B2C, direct to customers.
Yeah, how you are planning to scale the product? Like who will help to manufacture a product, if you are going for a very large scale, who helping you to manufacture a product?
Okay, so currently we are using all 3D printed parts and in low scales. For mass manufacturing, we'll switch to injection molding, which can produce a lot more parts in less time. And we'll also make PCBs and reduce the size. And we'll also tie up with a manufacturer to better manufacture this product.
See, I'm okay with all your innovations, all those things, but you have to see the size of the spoon. You have to you have to research the entire diameter, the entire radius of the spoon, so that you could be getting more information based on that. So research with lot more Parkinson patient, with lot more autism patients. Like I just want the spoon size to be like based on the feedback. Please consider the spoon size based on your feedback.
Yes, in the final product, we will reduce it to the optimum 30 mm diameter.
With your innovation, it's completely an awesome product. Please go with it, okay?
Yeah, and one more thing, I just want to add one more thing. We presented this in a few competitions also, in a robotics competition called as World Robot Olympiad. This is an international competition where we presented this in Germany in last November, where we won the first place and represented India.
That's nice. Thank you.
Thank you. Thanks a lot.
And now it's time for judges' opinion about the pitch. You folks are rock stars. Keep it up.